mostly wrong about why ice is slippery. It's not just because it melts when you step on it. That's the old school scientific explanation, that friction makes heat, heat melts the ice, and you slide on the water. This is what we're taught in science class, but it turns out that that theory only works near the melting point. On really, really cold days, you'd need much more heat or pressure than your feet or skates can produce. Experiments show that the ice at the sliding surface never even reaches 0 degrees Celsius. So why are we still sliding on it? Researchers have just shown that the slippery layer on the ice isn't mainly melted water, it's mechanically scrambled ice. When you slide, the motion puts a shear stress on the crystal lattice, basically rips apart the neat structure and turns the surface into a thin liquid-like layer. It's not ice and it's not normal water, but a messy, disordered in-between state. The technical term for it is displacement-driven amorphization, which sounds intense because it kind of is. Think of it like this. You're not warming the ice into a liquid. You're disordering it into something that behaves like a liquid. And when you think of it this way, suddenly some old puzzles make sense, like why skiing feels sluggish on very cold days. The old theory said it must be because it's too cold to melt. The new perspective says that the amorphous layer still forms, but at lower temperatures it becomes thicker and more viscous, like a cold gel, so you get more drag. It turns out the ice isn't that slippery when you just stand still on it. The slipperiness is activated by your movement. You are literally creating the lubricating layer with every step or glide. It's about mechanical force. Slipperiness isn't something the ice always has. It's something that happens to it when you move across it. You're not melting the ice. Your movement shreds the crystal surface into a liquid-like mess, an amorphous layer that you only make when you move. Isn't that wild?